Okay, so here we have just a compound. So it can't be one of the synthesis. It'll be a decomp of some sorts if it's just a compound. Okay, it could be one of these three, what I call special decomps. Okay, or it could just be the elements breaking apart. Do you see that it's this one? Okay, so that means this is XCO3. So my X is going to be AU, so it says in the pattern that AU goes with O plus CO2. Well, anything that's on the other side that is not in covalent compound, we're going to have to crisscross reduce to write correctly. Okay. Questions first about how I came up with AuO plus CO2 before we talk about, we're not done, but I just want to ask if you understand how I knew AU went with O and CO2. Any questions about that? Okay, now if you look up AU, because remember we have to crisscross reduce over here, if you look up AU, you're going to see that AU can be, at a minimum, AU can be a 1 or a 3. So I need to know which one it is. To do that, I have to go back here. This worked on last unit. I'm going to split this, right? Remember that this is really a 1 here. And I know that remember what we do here. We take the charge, so minus 2 times one of them. We take the charge times the number present. So I get a negative 2 here. So I have to have a positive 2 on this side. Then I divide by however many are here. So I divide by 2. We multiply on the negative side. We divide on the positive side. The back half we multiply. The front half we divide. So then we end up seeing that AU in this case is the plus 1 AU, not the plus 3. So then I know it's plus 1 here and minus 2 for oxygen. I crisscross reduce, so I bring this 2 down, and I bring the 1 down, but we don't bring 1s down. Okay, and now we need to balance. Questions about, first, remember we want to get rid of our plus and minus charges. We don't want them to look like they're part of it. Before you balance, questions about how I came up with the AU2O piece. Who needs clarity on that? Okay. Everybody seems to be okay. So we have 2 AUs on both sides, 1 carbon on both sides, and 3 oxygens. Notice 3 oxygens because I have 3 here, and 2 plus 1 is 3, so this is already balanced. This is already balanced. Questions about number 4? Okay, number 5 then. All right, number 5 is the first time we've run into this kind. We haven't mentioned combustion. This is a combustion. What you're going to have to memorize, there's nothing really to use on the chart for combustion. What you're going to have to memorize is if you have a hydrocarbon, so that is a, let me write that again. I don't like how close that is. If you have a hydrocarbon, that is a hydrogen, carbon hydrogen piece together. No matter what the numbers are, you're going to have at least 1 carbon, and you'd have at least 4 hydrogens if you had 1 carbon. But you could have less hydrogens if you have more carbons. Anyway, if you have a hydrocarbon plus an oxygen, you need to memorize it's going to make CO2 plus H2O. Now, I say memorize, but you could write it down on your periodic table or on your formula page with the arrow if you want it somewhere. So this is a combustion, right? Anytime we have a hydrocarbon plus an oxygen, we automatically will know our products are CO2 and H2O. These are the easier ones. You just have to memorize it. And then we're going to balance. Any questions about what I mean by hydrocarbon? Now, I could have other things with this hydrocarbon, right? I could have other elements after the hydrogen. But if I have a CH piece that starts, then I'm going to consider that a hydrocarbon, plus an oxygen going to CO2 and water. Okay, take a moment to balance this. So to balance this, I would start by putting a 5 in front of carbon dioxide to get my 5 carbons. Remember, with a combustion, we leave oxygen to dead last. We don't even consider oxygen until the end with a combustion. That's true with most, but for sure with a combustion. We're going to put a 4 here to get my hydrogens balanced. And then I see that I have 10 oxygens plus 4 oxygens, which is 14. So I have to put a 7 in front of oxygen to get it balanced. A 7 in front of oxygen to get it balanced. So 1754 makes this balance. Questions about number 5? Okay. Number 6 then. Here we have 2 compounds. So we know it can't be a decomp because there's only going to be 1 compound. It could be a synthesis, and I don't see something with oxygen or something with a chlorine, so it's not a synthesis. So now we have to decide if it's a common gas. Okay, and this piece up here on top of the words is the piece I had you add to your ion sheet yesterday. So we're asking ourselves, does it end with a salt? Do either of them end with a sulfur? No. Do either of them end with a carbonate? No. Do either of them end with a sulfite? No. Do either of them start with NH4? Yes. So this is a yes. We have that, don't we? Now, if it's a yes here, it also has to be a yes here to get the other side. And I also have a hydroxide, don't I? So therefore, I know it's going to be NH3 plus HOH plus my X with my Y. So let's talk about what that looks like here. This is my Y, and then there is my X, right? Oops. Yeah, I did that right. So sodium is my X, so Na, and then my Y is ASO3. Okay, so I'm just following the pattern here. This is the XY is the salt that's described in the words. Okay, we know NH3 is good. We know HOH is good. It told us exactly what the formulas are. But when we have an unknown combination, or a random combination, so to speak, we have to crisscross reduce. So this is a +1 and a -3. So the 3 is going to come down and the 1 is going to come down. Questions about the chemical equation before we work on balancing? Questions you might have about any of those pieces?
Where did you just get the +1 and the -3 from?
Okay, good question. I looked up sodium on the ion sheet and I saw that sodium is a +1. So that is in the first column at the bottom of my ion sheet. And then I looked across the 3 top sections and found ASO3 to be a -3. Does that make sense? And then I crisscross reduced. Brought the 3 down, brought the 1 down. Okay, any other questions before we balance? I see that there are 3 sodiums, so I'm going to put a 3 here in front of sodium. I don't know why I started with sodium. I could have started with ASO3. ASO3 was 1:1. Hydroxide was 1:1. Then I would have done sodium and put a 3 here. So I'd put a 3 back in here to get my 3 hydroxides. My nitrogens are 1 and 3. So I got to put a 3 in front of here to get my nitrogens balanced, right? I have 3 nitrogens and 3 nitrogens. So now what I have left is my hydrogens. So I have 9, let's try that again, 12 hydrogens here. 4 times 3 is 12 on this side. I don't count the OH hydrogen because I already counted it with the OH. So now I need to get 12 hydrogens on the other side that are not part of the OH. I have 9 here, plus 3 more, so it's balanced with a 1, 3, 3, 3, 1. 1, 3, 3, 3, 1. Questions for clarity on this one? Okay, number 7. Okay, for number 7, we have a compound plus an element, so it can't be a decomp. Notice I'm always starting in this space, right? Is it one of my synthesis? Well, I have to have something with an oxygen, so it's not that one. Something with an oxygen, it's not that one. Something with a chlorine. I do have something with a chlorine. It has to be plus an oxygen, and it is. So then I assume it is one of these. It is this one. I have XCl6 plus O2. So I'm going to do X, which is MnClO3. But remember, new relationship, we got to crisscross reduce it. I look in the Mn box on my ion sheet and I see that it can be a 2, 3, 4, 6, or 7. So I got to go figure out what it is. We will assume for this course that the positive charge doesn't change. So we're going to split it. We're going to look up the charge. Cl only forms -1s, right? The ion for chlorine is Cl1-, right? So the Cl1-, this 6 says there's 6 of them because it's monatomic, and you use the numbers when they're monatomic. Otherwise, you have to have parentheses. When they're poly, you have to have parentheses to have more than one. So that means Mn must be a 6, and there's one of them, right? Because there's a 1 there. So then 6 divided by 1 is still 6. So then I know this is the +6 Mn, and it's with a -1 ClO3. So I'm going to bring my 6 over. And then I'm going to balance. I'm going to move this down some. Oop, can't do that. Okay, questions about what I've written first. We would want to get rid of this plus and minus part, but questions about what I've written first before we balance. All right, so we have 6 for chlorine on each side. We have 1 Mn on each side, but I have 18 oxygens on the right, so I need to put a 9 here to get 18 oxygens on the left, and then it's balanced with a 191. Balanced with a 191. Okay, questions number 8 then. Sulfuric. Remember that an ic acid goes to 8. And if it's an ic acid, we have to see if it's a hydroic acid or it's just an ic. It's just an ic. So I'm going to do sulfate. Sulfate is SO4 2-. So then I know this is H2SO4. I know sodium is a +1, hydroxide is a -1. I get that from my ion sheet. So NaOH. Now, it can't be a decomp because there's 2 things before the arrow. It's not this one, it's not this one, and it's not this one, so it's not a synthesis either. Then the next place you go if it's 2 compounds is your common gas area. I do not see a sulfide. I do not see a carbonate. I do not see a sulfite. And I do not see an NH4. So it also is not a common gas. So then I'm going to know that it's a double replacement. I'm going to anchor the backs. I'm going to put the negatives, the back half, the SO4 with some space in front of it, plus the OH with space in front of it. So what I'm calling this is my back, and this is my back. So I'm putting them in the same order. I'm going to switch the fronts, so Na goes with SO4 and H goes with OH. But I built new relationships. So I got to think about how they go together. This is a +1 and a -2, so I should have a 2 here. This is a +1 and -1, so they look great just the way they are. Now, I want to point out, and I think I did this yesterday, I could also have written it like this. There's no rule. It's just my pattern of teaching it to you. You could have written it that way, right? Doesn't matter what side they're added on the same side of the arrow. It doesn't matter what order I put them in. So I could have done either way. I could have done this either way. But we do need to balance either one of them. So I'm going to balance the one I have written fully. I see 1 sulfate and 1 sulfate, 1 hydroxide, 1 hydroxide. 2 sodiums and 1 sodium. So I'm going to put a 2 here. That gets me 2 sodiums. But also gives me 2 hydroxides. So I got to put a 2 here. Now it gives me 2 hydrogens. But I have 2 hydrogens. So it's balanced with a 1, 2, 1, 2. Questions about any of that? Okay, number 9. We got to figure out how to write this first. We know Mg is a +2 from my ion sheet. I know chlorine is chloride is from chlorine. Chloride is a -1. Plus an element by itself. I got to think about Brinkelhoff. Pardon me. I think I might be getting the hiccups. Let me grab a drink. Brinkelhoff, yes or no? That's a yes. Okay, questions about what I've written there on the left-hand side, the reactant side. I just crisscross reduced and considered Brinkelhoff, yes or no. It is not a decomp. It's not this one, it's not this one. It could be XCl. I have an XCl, but I don't have an O2. I have an XCl, but I don't have an O2, so it's not this synthesis. So my only option is to use the activity series chart. Remember, we can only use this if it's an element in a compound. We can't use this chart for compound, only for compound element. All right. So bromine is the thing that's alone. Bromine is going to try to kick out something like it. So bromine can only kick out things in its same column, just like the metals can only kick out metals, non-metals can only kick out non-metals. So bromine is trying to kick out who? Chlorine. In order for bromine to win the battle, right, it has to be higher on the chart. And bromine is lower, so no reaction occurs. You're literally going to write the words no reaction or no Rx. Let me say that again. Bromine is alone, so it's going to try to kick out something in the compound. Bromine can only kick out something like itself. So nonmetals can only try to kick out nonmetals, and metals can try to kick out metals. So bromine would only win the battle if it was higher than chlorine, and bromine is not higher, so it loses the battle and no reaction takes place, therefore there is nothing to balance. Questions for clarity on number 9? Okay, number 10. Let's try to do it in order here, Peachy. Okay, we have aluminum that's by itself, and it's not Brinkelhoff. So it's just aluminum. When an element is by itself, as a reminder, it can either be a Brinkelhoff with a 2 or just by itself. That is my only 2 options when an element is by itself. So aluminum is by itself, and my only option is just to be aluminum. No subscripts because it's not Brinkelhoff. Again, when an element is by itself, it can either be all by itself or one of the 7 Brinkelhoffs. So only 7 by themselves get to have a partner. Everybody else is literally by themselves. Okay, so this is +3 and -2. So this is Fe2O3. I just crisscrossed reduced that. It can't be a decomp because I have 2 things before my arrow. It could be one of these 2, right? Because remember, it doesn't matter what order I add things, right? I do have an XO here. FeO is an XO, but I don't have a CO2 and I don't have a water, so it ends up not being a synthesis. So nothing for that chart. Now I'm going to look here. Okay, can aluminum replace iron, right? Aluminum's the guy that's alone once one of the dances. Aluminum is here, and iron is down here. So aluminum wins because it's more reactive, or in what I've been saying, it's higher, more powerful. So aluminum goes with oxygen, and iron is left by itself. Now, I can't just leave them over there. Every time on that right-hand side, you have to crisscross reduce and Brinkelhoff, or Brinkelhoff. So this is going to be a +3 and a -2. Where do I get that? From my ion sheet. So aluminum is going to be Al2O3. Aluminum oxide is Al2O3. That's just a crisscross reduce. And iron is by itself. It's not one of the Brinkelhoffers, so it stays as just Fe. And now you need to balance. I see 2 aluminums, put a 2 here. I see 3 oxygens. I see 2 irons. I'm going to put a 2 in front of iron on the right-hand side, and it's balanced with a 2, 1, 1, 2. 2, 1, 1, 2. So the only time you can use the who's more powerful trick is if you have a element and a compound. Okay, questions about 10 before we go to 11. Okay, number 11. I have two compounds, so it can't be a decomp. It could be one of these synthesis. It's not this one. It's not this one. It's not this one because it doesn't have XO or XCl. If it's two compounds, I would check this area next. I do have a sulfide and an acid, right? HY represents an acid. So I do have an XS plus an HY, don't I? So then it's going to be H2S plus X with Y. X is SN, Y is Br. If you look back onto the side, if you follow this pattern. Now, I can't just leave it. H2S is great because we know it's H2S because it told us so, but these are unknowns, right? They could be anything depending on the problem. I have to figure out how they go together. So I got to figure out what the charge of SN is, and I see that SN can be a 2 or a 4, so I have to go back over here or think through this, go back over here or rewrite it and think through it. Sulfur is a -2, and there's only one of them, so that's -2. Tin then has to be a +2 to start, divided by 1, because there's only one. So I know this stays as SN2+. This is what it actually would be, right? SN2+, I'd crisscross reduce. That's just kind of thinking through that piece. So then this is a +2 and a -1. So I'm going to put a 2 after my Br. Questions about how I got SN to be a +2 or why I wrote any of it that's on the screen. Haven't balanced yet. I just want to make sure you don't have any questions about the pieces I've written. Okay, let's balance now. I have 1 SN, 1 SN, 1 S, 1 S, 2 BRs. So I'm going to put a 2 in front of HBr to get 2 BRs, which gives me 2 H's, which I need it on the other side, so it's balanced with a 1, 2, 1, 1. It's balanced with a 1, 2, 1, 1. Questions for clarity on number 11. I hope you're starting to see the questions and the way you want to think through this. You will have that formula page and a periodic table to use, so you'll have those tools to help you digest through this. Can't promise that would happen in a college chem class, but you'll always have mine to reference to help you start memorizing and practicing if you take college chem. Okay, no questions on 11? Let's go to 12. So this can only be a decomp, right? Because there's only one thing before the arrow. So is it one of these? Oops, I didn't mean to put a mark on that. It's not one of these. It almost looks like this first one, but that's cobalt, isn't it? Because that's a lowercase o. So it's none of these decomps. So the only thing it can be, if it's one thing before the arrow, is the elements breaking apart. And we don't have a lot of these, but if you have only one thing before the arrow, the only thing it can be, if it's not one of these decomps, is the elements breaking apart. Cobalt is not Brinkelhoff, so it's just CO. Oxygen is Brinkelhoff, so it's O2. And then you're going to balance it. So we see that we have a 2 for cobalt, but then I have 3 and 2 oxygens, so I got to get them both to 6. So I put a 3 in front of O2 and a 2 in front of the cobalt product, the cobalt oxide piece. But then that gives me 4 cobalt, so instead of a 2 in front of cobalt, I'm going to change that to a 4 to maintain it as balanced. So 2, 4, 3. Okay, give me just a second. We're going to go to whiteboard FI here, and you're going to do number 13. What time is it? Oh yeah, we got time. Okay. I'm going to put a link to the whiteboard FI page that I want you to use in the chat here in just a sec. I'm creating it. So if you could go to whiteboard FI, and here in the chat is the link. You're going to try number 13. I'm going to give it to you, so give me just a second to get it. It's going to take just a moment to get this all set up. So you get on there, and I'm going to give you the piece so that you don't have to write it all out. But it will erase, so just be aware that it will erase. I'm working on that. I'm trying to save you time by giving you the piece that you need. Okay, so now you're going to